Before to start, I would like to thank Cecile and the Varves Group teams from this invitation. Is a good opportunity for me for present recent works that started in 2018 with the coring field mission. There was a lot of work, especially for the chronological model of the sequences, because it's quite difficult in this area of the world. And this work was published a few months ago, as Cecile told before, on climate of the past. And so I'm Carlo Mologni. I'm a researcher at the Institute for Development in France, and I'm working at the Geoscience Azure laboratory in south of France, in Nice. So now, this day, I would like to speak, to talk to you about an original laminated and seasonal sediments from a tropical desert. So coming from a lake, residual lake in the central part of the Afar depression between Ethiopia and Djibouti. So the work was focused on Djibouti, and is quite different to the other presentation that was hosted by the Varves Group, because we are not in Northern Europe on high latitudes. We are in very, very low latitudes. We are around 10 degree north, and we are in a tropical desert. So normally the landscapes that we found in those tropical desert are like the photos, the picture that you see in this fourth slide, in which there is no water. So the water becomes the history of water. So from the past to the present and also to the future represent a good challenge to understand for science, for society, for economy. And is from this point of the reflection that I would like to start my presentation, that is based on the assumption that's of the given by the FAO, for the Agriculture Organization of the United Nations, but also of the last reports of the IPCC, that those area of East Africa, so arid or semi-arid area are particularly impacted by the climatic change in terms of droughts and floods. We are not speaking about the big long-term droughts or long periods of rainy periods of floods, but we are speaking of a very and short abrupt periods of droughts, so that we can happen in few years or in few months during the years, and also about flood that can be very instantaneous. So this is a quite problem, because today in East Africa, for study this kind of change for the past and for the future, we don't have very high resolution records of the climatic change for studying this kind of atmospheric and ocean impact anomalies. So this research, this study start from this assumption that we need more and more on this kind of area, high resolution study for study this short-term type of impact in East Africa. So on this study, we focused on Ethiopia. So is a big country, but as you see from these two pictures, in which they are represented the extreme floods over the last 4 years, but it was a study of 2019, and of the aridity index on the picture on the right, the areas in which we have the majority of floods and also of peaks of aridity, so also peaks of this desertification and short-term droughts, are represented by the deserts, not by the highlands. So those converging type of impacts are interesting to be studied together because there are two kinds of risk that we are facing today in East Africa. This because of some atmospheric ocean teleconnection anomalies, because the rainfall variability over East Africa is mainly influenced by several modes of climatic variability. So the first is the El Niño Southern oscillation, so that we can see represented here in this future, that kind of teleconnection that is combined with the Indian Ocean dipole and also by other two kinds of teleconnection. But the two main type of anomalies of abrupt precipitation or short precipitation and short droughts are driven by the combination of the El Niño Southern oscillation and the Indian Ocean dipole anomalies. Here we have represents the process of this kind of anomalies that's concurred with a positive IOG in the East Pacific El Niño and the negative IOG in the West Pacific El Niño, that can amplify the short precipitation in East Africa. And what about the droughts? They normally are caused by warmer SST over the Western North Pacific, strengthened the water situation that suppress long rains. So is a kind of impacts that are not as you can say, prevedible on the short term, because there are a combination of a different ocean atmosphere teleconnection. This record that we can see here is the measure of the SST anomalies over the Pacific, so linked to El Niño. And if we try to compare these anomalies with the years of droughts and famine in East Africa that are represented with the red star, we can see that every time in which we have these short-term droughts linked to droughts in East Africa, they are linked to the anomalies on the SST temperatures over the Pacific and the Indian Ocean. So the challenge of geoscience, of paleoclimatological study or climatological study is understand how local and regional hydrosystem in East Africa respond to short-term ocean atmosphere anomalies. This is because today we have many studies that are interested in long-term climatic changes on this area of the world, but the low spatial temporal resolution of climatic models, as well as the low chronological resolution of the recording and the lack of local to regional data on climatic impacts, make this difficult, this kind of challenge, but is the main objective of this kind of study and also of my scientific pathway in East Africa. So what I'm searching and what was searched during this kind of study is a seasonal sensitive high resolution record, which allow us to connect local to regional impacts and global changes, because the answer about the local impacts have to be local and regional and not local. So in this kind from this kind of scientific problem, the lacustrine core and laminated core, as you can see here on the lower part of the slide, can be a solution and can be the archive of good data for study this kind of Earth atmosphere processes and the local impacts. For the study, we search an area that is appropriate for this kind of scientific issue. So an area in which we have a lack of high resolution data, that this is the Afar region here that you can see in the square, in which there are no data or actually local and present data for the moment, is a tropical desert, so in which both droughts and both floods can have a heavily impacts on the landscape. Is a region that is characterized by a seasonal water source regime. So you can see here in the right the two precipitation regime that we can have on the highlands and also in the Afar region, that is characterized by the peak of precipitation during the summer and lack of precipitation, especially in the Afar region during the winter. This is important because if we want to study the anomalies that happened in these two seasons, we need to have a framework, cyclic framework of precipitation. So this is the case, and it's very important for us. We need also an area that is characterized by high topoclimatic catchment gradients. So here in the lower part, we can see the distribution of the precipitation over the catchment that is investigated in the study, and also on the right, in the lower part, the evaporation rates in the study area. That's important as the same reason that I explained before about the magnitude, because this kind of parameters, so the precipitation, seasonal precipitation on the highlands and high evaporation on the lowlands, increase the impacts of floods and droughts in the lowlands, so in which the study is focused. And we selected also this area because also is a receptacle of Indian Ocean moisture sources. So what is interested by this study by us, because it's kind of sources of all this kind of ocean atmospheric interaction anomaly that's come from the Pacific and the Indian Ocean, that are represented here in the lower left figure by the arrow with the number 4, in which we are all the contribution of the moistures that come from the east, that are represented by this study, Vista and Stoneberg, by the 53% of the parcel of moisture of air that's represented in the precipitation in this area, so in the highlands. And also, we try to focus on an area that is favorable in what's all concerning the geomorphic condition. The geomorphic condition of this area that actually is represented by the Awash River catchment and the Lake Abe catchments. The geomorphic context is given by the changes in hydrology in that past that was reconstructed by another study that I did a few years ago, in which I was able to reconstruct, thanks to the recognition of morphological feature of paleo-shorelines, and also with the dating of lacustrine carbonates as stromatolites, the lake fluctuation over the Holocene. So we have to think that this basin during the Holocene was occupied by the mega lakes. So if in the past the Lake Abe basin, as you can see here on the right, was occupied by 6,000 kilometers square of water, now the only residual lakes are represented by 200 kilometers of water. And here we can see also the regional connection with other basins that are located higher, so in the highlands with the Ziwa-Shalar basin. And this gives the geomorphological patterns of the lower Awash plain that was investigated by this study, that is represented here in this illustration. So here, so we are in the center of the Afar region, in which we have normally in an average of 200 millimeters of precipitation by year, contrasted to the 200 millimeters of precipitation in the highlands. So is what we're searching. So those residual lakes that are the residual lakes of the big Holocene lake that occupied all this area are in water, so are flooded only thanks to the Awash River waters that come from the highlands. Here, so we focused is an endorheic basin, so we have no any outflow on the sea today. So the last basin of the hydrological history of the Awash River is the Lake Abe Basin that is located here in the lower right of the map. We didn't choose to call this lake because the last branch of the overflow between the lower Awash Plain and the Lake Abed is interested by the Damale volcano and by other geomorphological features that can disturb the transfer of hydrosedimentary information on this last basin, on this endorheic last basin. So we focus on two other residual lakes. So the Lake Gemery, that is a prodeltaic basin located on the footwall of this fault of the Gemeric fault, and the Afambo Lake that, as you can see here in the lower right picture map, is protected by a little basaltic horst. So from in one side, we have a deltaic lake, that is the Gemery Lake, and on the side, another deltaic lake, but is protected. So the water influx in these lakes, come more slowly and theoretically with a less accumulation sedimentation rates. So the coring operation of these two lakes happened in December 2018 in a light mode. So thanks to the expertise of a team from the Editem laboratory in Chambéry and the Alliance laboratory in La Rochelle, we was equipped by very light equipment. So because the transport of the material and the logistic of this mission in this very remote area, because it's very difficult to attend this area, allowed us to selectionate the equipments in a light way. So thanks to Fabiano and Emmanuel Mallet, they built a homemade platform that is represented here in this picture. IX Blue Ecos 5000 chirp eco sounder that is very little material for this kind of fieldwork, and also with a homemade modified Nashi-like corer and crossed with a UV technology for the short course. So the Nash-like corer for the long course and the UV technology for the short course. Here we have an example of results of the seismic surveying over the Gemery Lakes, in which we can see many discontinuities, and in particular also on the top here some paleochannel represented in the bottom of the lake. So that learn us about the drying, firstly the drying of the lakes that happened in the past, but also for locates our course. So in total, we retrieve 7 cores, so 2 from Lake Afambo on the south, and 5 from the Lake Gemery, to try to represent all the spatiality and the morphology of the sediment at the bottom of the lake. We start with the presentation of the core game 1803 and 04B. This is a master core composed for two different sections. This lake is characterized by very, very shallow water, so it's a 7 meters deep lake. It's a very alkaline lake, so it's characterized by 9 values on the pH and very high conductivity values. The sediment of this core is quite, there is no lamination, there is no varve, is a very homogeneous core, characterized by homogeneous clayly brown sediment, as you see here, characterized also by several discontinuities all along all is deep. That's this discontinuity are interpreted as a erosion and sedimentation interruption feature. And also, as you see on the top, between 20 and 40 centimeter, this lake sediment is characterized by the development of a paleosoil. So that is in accord with the seismic profile observation that I showed you just before. So is a sediment composed by high heterogeneous inputs, so characterized by but iron, titanium, and aluminum inputs that are co-varying during the time, and that give not us a lot of information. What is interesting about this sequence is the chronology. So for attain this result, we cross radionuclides elements that you can see here on the top of the core that allow us to determine the first 60 centimeters of chronology of the core that show a resolution of the sedimentation rates about 1.3 centimeters per year. And here in the bottom, we applied also a paleomagnetism method for try to investigate the whole core. Let's give an age from his bottom around 1,100 years AD. So is a core so that's potentially records so the deltaic and lacustrine activities of the Wash River, and that's cover in low resolution the last 900 years of lacustrine deltaic dynamics. Inversely, we have the second core that make the focus of the study, that is the Afar 1802. Is more deeper. It was retrieved in a more deeper lake, so that makes 18-meter deep, with a similar pH and a similar conductivity, which so is still characterized by alkaline condition. Inversely, to a geomeric core, here we have a laminated sediments with an alternation between two kinds, mainly two kinds of sediments, black, gray, brown sediments that here are called as a F1 laminae. And the second is the F2 and F3 laminae that are represented by the orange color and the white color that are more thin. And that is alternates the F1 laminates all along the sequence. So here we have another history about major and major and trace geochemical elements, in which we have the alternation between heterogeneous elements here represented by titanium and calcium or strontium. That's are representing a very clear alternation of these two features. So we have the sedimentological evidence, but also the geochemical evidence of the sediments, of the alternation of the sediment. Here on the right, we can see very well how thanks to the crossing of XRF analysis and also ICP-MS samples that you can see located here all along the sequence. That the F2 and the F3 lamines are more carbonated, and the black brownish lamine are more terrigenous, so composed by less carbonated. This is the first interpretation that we did give to this sequence. That after was focused thanks also to the chronology that was very difficult to get. For that, we crossed three methods. So still the radionuclides elements all along the core that you can see here, with two different plateau of sedimentation rates. One sedimentation rate on the bottom, between the bottom and around 120 centimeters, and then a reduction of the sedimentation rate from the upper part of the core. Thanks for the localization of the post PBBT bomb of the nuclear test, the last nuclear test that we had, we were able also to cross this kind of information, to cross also the counting of the lamine and also the radiocarbon age. That give to us a solid age model that give us a cover of the last 50 years in high resolution, because we have 10 to 16 millimeter years of sedimentation rates. It means that we have an average of lamina sedimentation of 10 centimeters per year all around the core. About this lamine, we tried also to get a more high resolution about this model, in which we cross the radiocarbon ages, as this example in the bottom, in which in between two ages we had the occurrence of a perfect number of F2 and the F3 laminae, representing the years between 1990-22 and 1990-97. That is confirmed as the yearly character of this kind of sedimentation. So it was at this moment that we was able to say that this kind of record, it was a seasonal record in a high resolution, because we had around 10 centimeters of yearly sedimentation almost all around the core. A more deep analysis of these fascias, so give us the confirmation that the sources of the F1 lamina, so the terrigenous lamina, by the comparison with the rift basalts of the Afar region, as well as the Blue Nile catchment river mud, we found occurrence about this kind of source. So during all the time of the sedimentation, theoretically we didn't have changes of sources along the core, and we can see here the clear differentiation between the terrigenous inputs represented in the F1 lamines versus the autogenic, as was interpreted, the autogenic carbonate precipitation of the F2 and the F3 laminae. Here we can see clearly the differences in thin section analysis, in which in F1 fascias we have coarser, high organic, and heterogeneous F1 sediments. And on the other side, we have autogenic or biochemical precipitated of F2, F3 laminae. These two kinds of sediments, so now that we say that was yearly sedimentated in the bottom of the lake, we are able to say that the F1 phases are likely deposited during the monsoon period, so during summer, between March and October. So during the high monsoonal activity on Ethiopian highlands. And the other side, we have the kind of sediment in which we have the stop of the not the stop, but the strong reduction of the freshwater inflow of the lake, the strong evaporation rate. So we are around 2,000 millimeters, not 2,000 centimeters of evaporation rate in the central Afar region. That's from our point of view is triggering during this period. So in the winter, the high evaporation of water, the saturation of minerals and light minerals in the water, and the autogenic precipitation of micrite and sparite on these F3 and F2 lamines and fasces. Here in this picture about the F3 fasces, so we can see also an interruption of microlamination of the sediments that is likely attributed to this strong autogenic precipitation of minerals. And then after the progressing on a new wet period of the year. For try to correlate these two very different sequences, we cross our main geochemical tracer, so the titanium versus calcium reports, and also the modeling of the water lake surfaces over the last 50 years by the collecting of data, of the Landsat data, and by a global surface water dataset algorithm. And so we can see clearly when we have in the lake Gamari the stopping sedimentation given by the sedimentologically by the developments of a palosoil in the middle of the lake, we have a strong reduction in 1991 of the lake waters and also of the drying of Lake Gamari by satellite imaging. During these periods in the Lake Afambo, we have a very dominance of carbonatic and strontium values that's allow us to determine these periods as a drought, a regional drought in this lake. So we had the concomitance between sedimentological record, seismic profile record, and also a lake surface variation. During all this time, so between the 70s until the 2014, we had a quite constant sedimentation rate since the apparition of a dam, construction of a dam a few kilometers up valley of the Awash River that is in concomitance of a very high increase of sedimentation rate. So is from this moment that we realized that we had a sediment sequence that allow us to reconstruct the floods during the wet period during the summer and the drought during the winter. So that's what I explained just until now, but also to detect anthropogenic activity, the first anthropogenic activity that happened in this basin, and how this anthropogenic activity impacted the hydrosedimentary balance of this lake, and also about the availability of water for local population in this area. From this assumption, we built a theoric model of those two contrasting situation. So the prolonged wet period, as example, the 1918 to 1990 period, in which we have a strong terrestrial inputs given by the floods of the main Awas channel in Lake Gamari and Lake Afambo, and drought events in which drought events and also prolonged period in which we have a dominance of evaporatory processes with the integration of calcium and strontium in the lake sediments. From the study of the lake sediments and also of these kinds of geomorphic patterns and morphological lake bottom patterns, we are able to define the homogeneous clayey sedimentation of the Gemeri Lake as a homopycnal sedimentation. So without any layering, without any varve, so at the mouth of the main Awash channel, and hypopycnal sedimentation in the Afambo Lake that's come later after the transfer from the Gemeri water body or directly from the Awash River Delta. During drought events, so we have as one that strong event between the decade between 1991 and 1997. So the drying of Gemeri Lake and drying of all the channels in the Awas River Delta, and a strong reduction of the Afambo Lake with still hypopycnal sedimentation and also precipitation of calcium minerals, pyrite and micrites. For finish this study, we try to focus on the high resolution. That was the main focus and the main challenge of the study. So in the central figure, you have all the annual dry season laminae that are represented on a chronological data scale. And in red, the enhanced dry season, so the peaks of calcium and strontium that are in concomitance with the historical droughts that are recorded in Ethiopia. And so we find a quite good concomitance between the historical drought that was recorded by literature in Ethiopia and in East Africa, and our F2 and F3 laminae. To try to get out so the intensity of the flood season during the summer, we cross two kind of parameters. So the first parameter is the F1 thickness, so the heterogeneous laminae thickness, and also the D90 of our sediment. This kind of combination of sedimentological parameter was introduced firstly by Willem 2015 and 2012, thanks to the study of laminated sediment from the Alps. And for the study and also for other study, this represents an intensity proxy of our flood during the summer. If we compare the data, effectively we can see that from the bottom of our sequence we have high hydrological activity also in comparison with the modeled flow rate at 10,000, so at the mouth of the Lake Abe Basin. During the period of the drying of the Gameri Lake, we have a reduction of the two parameter, and then after the augmentation of the intensity of our flow and floods inputs into the basin and into the lake. So finally, we compared our data to the SSE temperature anomalies. And for the moment, this kind of correlation is only visual. So just we compare two cores, but there is a study that is ongoing by the team, our team, in which the goal is to modeling so all the SSE temperature anomalies and also the IOD anomalies, and cross that with our data and with flow rate modeling data sets. What we see about this visual correlation, that's during our regional extended drought between 1991 and 1997, we have a strong El Nino SST temperature anomalies. So is a confrontation for our data, as well as the other peaks of the SST El Nino anomaly that are according with F2 and F3 lamine along our sequence. So what are the highlights of the study? That we had a 50 years long high resolution drought and flood intensity seasonal record. That is the first that was provided in the region. So other example in Ethiopia, as Cecile said before, is the Babogaya Lake, the Tilo Lake, and other two crater lakes on the highlands. But for the lowlands, or where the impact of floods and the drought is more stronger, this is the first kind of archive. So in the Afar region, we show a concomitance between droughts and SST temperature anomalies that have to be improved with a modeling. We localized a prolonged El Nino anomaly impact in East Africa between 1992 and 1997. Then the correlation between strong El Nino impact and strong La Nina impact. If you can see, normally when we have a strong El Nino in the Pacific and the impact on in the IOD, just after we have also an increase of short seasonal rain in the continents, so in East Africa. And here we can see very well that, for example, during the El Nino 1997, that we have a strong drought that is represented by this very low peak in interregional input and a strong evaporative processing. And the years after, or in between 1997 and 1998, sorry, we have an intensification of floods in this area. And this is systematic. So this is a good point that's confirmed the theory that was advanced about the impacts of short rainy season in East Africa. And finally, what we highlight how the anthropic activity in this basin enhanced the increase of local soil erodibility. So if you can see in the upper part of the sequence, so since 2010, 2009, 2010, in this area, as I said before, we have the construction of the Tendao Dam project. So the construction of a dam, but also of the spread of agriculture fields in a tropical desert So what happens that the channel, the agricultural channel, they take a lot of water and a lot of sediments from the main river awash course. And the result is an increase of sedimentation rate that is interpreted here as an increase of erodibility of soil in this area. For finish my talk, I would like to propose you two pictures that I took the last October in the Lake Abe Basin, so not so far from the lakes that was presented here. So in one side, we have the representation of the nomad population that exploited since 1,000 years those very, very arid landscapes. So that all their mobility and all their economy is based on the access of water points. And the other side, we have the construction of massive channels in the desertic plain that takes water from the Awash River. So there are two contrasting situations. One, the local population with a millennial tradition of and in millennial type of economy, nomad economy, and the other side, the extensive exploitation of multinational in this area. That's deprive water all the awash plain and also the lakes. This is just a reflection for say that if in the near future we will have a period, a situation and an impact of El Niño anomaly as that's recorded between 1991 and 1997, it will be a big problem from this population because it will represent the drying of the lakes and also the drying of this kind of channel that and the point of water that are important for this population. So this is just a last reflection about the social impacts about this kind of a social and local impacts about this kind of atmosphere oceanic anomalies in this area. So I would to thank you for the listening, and I'm waiting for you for answer.